Good morning everyone gathered here. My name is Karthik and my project is on the title Fatigue Life Evaluation of Electrical Bolton State Structured Connection. My external guide is Dr. S. Vishnuvardhan, CSIR SCRC, and my internal guide is Dr. M. Selvakumar, Professor, Beltec Tech Engineering College. Introduction. Generally a structure may fail under a static loading, and some structures failed under loading much below their real strength, and the concept of fatigue was then only introduced. Fatigue failure is nothing but the failure of material under repeated cyclic loading, in which stresses will be much lower than the yield limit of the material. Types of fatigue: low cycle fatigue and uncycle fatigue. The low cycle fatigue occurs at below 5 million cycles, and the high cycle fatigue occurs above 5 million cycles. Fatigue life of a component is the number of load cycles that it can withstand before its failure. Next slide. Suresh. The objective of my study is to evaluate the fatigue life of a bolted connection and to compare that data with standard IS standards. Fatigue failure in connection. Generally a component fails predominantly at the connections, and hence a fatigue study is implemented for my connections. Bolted connections. In the different type of connection, bolted connections are taken for my study since they are very advantageous than other type of connections. Next, bolted butt joint. My study is on the butt connections, in which the metal plates are joined by sandwiching them between cover plates and providing bolted between them. Literature view. Vishnuvardhan et al. Has carried out fatigue life evaluation test on welded specimens, in which they have proved that the maximum stress value of 60% and above failed to satisfy the codal provisions. LCC studied the effect of a crack on the ultimate response of a joint, in which they found that the crack advancement in a specific bolt hole will initiate a crack in other bolt holes. Sokolov carried out fatigue life evaluation on top-rated bolt joints, in which they found that the fatigue life improvement is due to the clamping effect of the joints. Jose Maria studied the fatigue strength of bolts by experimenting in single and double lap joints, and they found that a larger load is transferred between the friction between the plates, and thus reducing the stress concentration factor, which increases the fatigue life of the bolts. Colin Rogers studied the failure modes of bolted steel connections, in which any standards does not provide design formulae and tables for steel sheets less than 1 mm, and he has formulated some formulas and tables for steel sheets less than 1 mm. Chakarlov carried out clamping, the effect of clamping force on bolted connections, and they found that there was an improvement in fatigue strength due to the compressive stresses, and it was found that the higher magnitude of load does not provide any improvement in fatigue life for higher torque values. The IS specifications has formulated the design standards for fatigue strength. In this, the construction details and detail category are provided, from which the SN curves are to be plotted. The construction detail is nothing but the number provided for each for a connection type, and the detail category, that value is necessary for SN curve data. Fatigue strength. The formula for calculating the fatigue strength of materials for normal stresses and shear stresses has given in IS codes are provided. These are the SN curves from which the stress values are to be found out, and these stress values are to be implemented in the material testing. We have determined some stress changes, and for our bolted butt joints, the construction detail is 1 of 3. So fatigue strength of material is taken as 1 of 3, and stress changes are taken as per the design standards, and the number of cycles as per the IS codes are calculated, and the material should satisfy these number of cycles before failure. These are the references I have. Sir, the specimens are in fabrication, sir. The experiment, we will carry out the experiments by this.